Thank you, Hans. Hi, everybody. I'm Francis Althofer from Econotech, which is a Belgian consultancy. I'm pleased to give you here a short presentation called Impact of the Economic Crisis on the EU's Industrial Energy Consumption. I'm glad you're here, and I hope you will remain with us because we will be in competition with a bigger event, the World Cup draw that will take place in Moscow in less than half an hour. The impact of the economic crisis on the energy consumption is a vast subject, but I'm only going to address two questions. Which is, first, to what extent is the decrease in the EU's industrial energy consumption after the economic crisis due to energy efficiency improvements? Energy efficiency improvements is measured through the unit consumption of industrial branches. And second question, what has been the impact of changes in production level of the industrial branches? The methodology comes down to decomposing the variation in energy consumption in the EU since 2007 into three effects: an activity effect, a structural effect, and a unit consumption effect. And this is done based on ODYSSEE data. ODYSSEE is a large European project on energy efficiency indicators. It has 28 countries participating, and it has set up a large database on energy efficiency indicators. On this website, you can find all the information about this project. The first chart here shows the decoupling of energy consumption from economic growth. You see here the blue line is the first line shows the evolution of GDP, and then you have the evolution of primary energy consumption, the primary energy consumption after climate correction, and the evolution of the combustion CO2 emissions. That's for EU 28, that means the 28 countries of the European Union. That's the EU before the Brexit. There is a dip in 2009 for all these curves, which corresponds with the economic crisis. After that, there is a recovery in the GDP and also in the energy consumption, but after that, from 2011, you see a growing gap between the energy consumption and the GDP, which shows the decoupling between both. And if you look at the evolution of by sector, you see that it's industry that has been most affected. It's industry's energy consumption that has most declined, and that's why I chose to focus this the presentation on what happens for the industry, for more precisely for the manufacturing industry of EU 28. I talked about three effects, among which there is a structural effect on the energy consumption variation. To have a structural effect, two conditions are necessary. First, a diversity of energy intensities. The energy intensity across branches. The energy intensity of a branch is its energy consumption divided by its value added, and it's expressed in tons of oil equivalent per euro. And the second condition is the diversity of activity variation across branches. Now, about the diversity of energy intensities, you see here clearly that there is a very big diversity with primary metals having an energy intensity which is maybe 100 times that of textile and leather, and the other sectors being in between. So that's the first condition is met. The second condition is the diversity of activity variation. We see here that there is indeed a diversity of variation in activity, and we see in 2009 in particular the effect of the crisis for the different sectors. We see, for example, that primary metals went down most with the non-metallic minerals. We see that cyclical sectors are those that tend to decline most at the time of the crisis and recover afterwards. And conversely, the green curve here shows the evolution of the food industry, and we can see here that we kept ourselves feeding ourselves during the crisis, but we could afford to postpone the purchase of a new car. There is also a diversity in variation in unit consumptions across branches, which you see here with the a sort of exceptional situation for the wood industry, where the unit consumption has increased tremendously between 2007 and 2014. In general, it's been more of a decrease in unit consumption, and an energy saving. Now I come down to, again to the breakdown of the variation in energy consumption since 2007. The three components are the activity effect, the unit consumption effect, and the structural effect. The activity effect is calculated as proportional to the production index of the manufacturing industry as a whole. The unit consumption effect is calculated as the difference between the observed energy consumption and the one that would have taken place if the unit consumption had stayed constant at its level of 2007. And the structural effect is calculated by difference. Now, the structural effect, in fact, is equal to the variation in energy consumption that would have taken place if the unit consumption of each branch had stayed at its level of 2007 minus the activity effect. This is really something difficult to grasp in this way. Napoleon said that a good sketch is better than a long speech, so I tried to make a good sketch. Here you see on the vertical axis the energy consumption from 2007 to 2014. So I don't have a pointer, so I'll try to explain without it. Starting from the 2007, you see the observed energy consumption. In this case, this is an example for a single branch. To explain, it's easier to start from a single branch. You see the observed energy consumption of the single branch, which in this case is decreasing. If you go upwards, the next line is that growing with the growth rate of the branch itself. So there you have the energy consumption that we would have observed in case the unit consumption of the branch had stayed constant. It's just growing like the activity of the branch. And the upper line, where it's written growth of industry, shows the energy consumption that we would have had if the consumption had followed the growth of the activity of manufacturing industry as a whole. Now, the next slide shows the breakdown. We are breaking down the energy consumption variation, which you see in red at the lower left side. The energy consumption variation, which is here negative because the observed energy consumption of the branch went down from 2007 to 2014. That is equal to the activity effect plus the structural effect plus the unit consumption effect. The activity effect is positive, the structural effect is negative, and the unit consumption effect is negative. In this example. So, the unit consumption effect represents, is a proxy for the energy savings of the branch. The structural effect, which is negative here, comes from the fact that the branch, the growth of the activity of the branch was smaller than the growth of manufacturing industry as a whole. It could have been the opposite. So now, if you so this is for a single branch. If you add this up across branches, you can add it across branches at the level of a country, and then you can also add it across countries. And if you add it across branches and across countries, then you get this result. Well, here you see the breakdown of the energy consumption variation is the yellow bar on the right for each year, and that is explained as the sum of the three bars that are just left to it. If we see for 2014, we have minus 17 something for the total energy variation. That is the sum of an activity effect, which is minus 7 for the industry, for the activity effect, and then something like minus 3% for the structural effect, and minus 6% for the unit consumption effect. Now, here we can see that in 2009 and 2010, the total effect is practically equal to the activity effect. So the consumption of industry just follow the evolution of the activity of industry as a whole. Now, starting from 2011, there we have the two other effects which are appearing, which is the structural effect and the unit consumption effect. And we can observe that so in fact, in absolute terms, in 2014, this corresponds to respectively 22, 12, and 18 million tons of oil equivalent for the activity effect, the structural effect, and the unit consumption effect. In total, 52 million tons of oil equivalent energy consumption reduction. Now, the unit consumption effect, as I said, is a proxy for the energy savings. It gives an indication of the level of energy efficiency improvement, but it's not a perfect indicator. It comprises not only the impact of energy efficiency policies, it also comprises the natural energy efficiency improvements, those due to technical progress and investments in new equipment, scrapping of old equipment. But it also remains imperfect, mainly because there are, within that unit effect, intra-branch structural effects. And examples of intra-branch structural effects are product shifts between energy-intensive and less energy-intensive products. This is particularly the case in the chemical industry, because the chemical industry, unfortunately, in the statistics, is a sector which comprises as well pharmaceuticals as energy-intensive petrochemicals. So if there is a shift from one to the other, there is an increase or decrease in the unit energy consumption of the branch, and it can end up in a rising unit energy consumption of the branch. Another type of intra-branch structural effect is a shift in type of raw material. For example, the replacement of clinker by blast furnace slag in the cement industry. If you do that, you reduce a lot your energy consumption, because the clinker production is a very intensive process. Conversely, if you abandon the use of blast furnace slag, which tends to be the case because with the closing of the oxygen steel industry in Europe, well, there's more clinker to be produced for equivalent production amount of cement produced. Then you increase the unit consumption of the cement industry. A third example of inter-branch structural effect is process shift. For example, the replacement of oxygen steel with electric steel. That saves a lot of energy. Now, some of these internal structural effects may or may not be considered as energy savings. That depends on the definition of energy savings, and it's up to each of us to make up his mind about what kind of energy saving he wants to evaluate. And this is something which is not enough, people are often not enough aware of. For example, if you replace oxygen steel with electric steel, that may be considered as an energy saving or as a structural effect. And there may be good arguments for doing one or the other. These intra-branch structural effects may be either positive or negative, and therefore energy savings may be underestimated or overestimated by this indicator, by the indicator of unit consumption. Now, if the calculation I showed before can be done by country, and here I show results for 6 countries which are the largest energy-consuming countries in Europe. You see, the situation is these 6 countries total 69% of the total EU 28 primary energy consumption. Among these countries, the unit consumption effect over the period 2007-2014 period extends from 0% in Germany. And in Germany, why 0%? Well, that's actually because there is an increase in unit consumption in the chemical industry, probably for the reason I just explained of infrastructural effect. And there is an increase in the wood industry, and that compensates for sectors where there is a decrease in unit consumption. So it goes from 0%, the unit consumption, from 0% in Germany up to minus 31% in Poland. The structural effect ranges from plus 2% in Italy to minus 11% in Poland for the same period. And you can also see that the activity effect reaches plus 31% in Poland, while there is a reduction of over 20% in Italy, in Spain, of the industrial production. Now you can make the same calculation by branch, and here the results of that are shown here also for Europe as a whole. And there, you can see the structural effect. So the total is shown at the bottom for the manufacturing industry as a whole. So the 4 bars, horizontal bars at the bottom for manufacturing industry are the sum of all the bars above. You can see that the structural effect is mainly due to non-metallic minerals, minus 3%, and primary metals, minus 2%, and is partly compensated by the chemical industry, plus 2%. So you see that for Europe as a whole, in the chemical industry, there's been an increase in unit consumption. And that is probably, as I said, for the reason of infrastructural effects within the chemical industry. The unit consumption effect is mainly due, well, to the chemical industry. Now, what you see here also is that what can happen is that for a same branch, energy saving in countries with a negative energy consumption, unit energy consumption, may be hidden by increases in unit consumption in other countries due to shift in products, in products, for example. now to conclude, the analysis here tends to show that the reduction in energy consumption in the years 2009 compared with 2007 can almost entirely be attributed to the decline in overall production of industry. But later, from 2011, the energy consumption the evolution of the energy consumption is due not only to industrial activity, but also to a reduction in branch unit consumptions and to a structural effect, a smaller weight of energy-intensive branches, and therefore a decoupling of energy consumption from activity. Well, you've seen that there are significant disparities across branches and countries, of course. So here, I thank you for your attention. For further information, you can go to the website of ODYSSEE, and I would like to mention that this presentation is based on a paper that was published in April, which you can download on this website under Publications and Policy Briefs. Now I'm ready to try and answer any questions you may have. Thank you.